our objective today is to be able to solve radical equations. Now, on this slide, you will see the steps. I'm not going to stay on this slide horribly long, so you want to maybe pause it if you need more time, okay? To solve a radical equation, you need to follow these steps. Step 1, isolate the radical. Notice we've got a keyword here, isolate, right? We want to get the radical on one side. I like to draw a picture. Let me make this smaller. I like to draw a picture for myself. Now it might be a square root or a cube root, but we want to get a radical on one side and everything else on the other side. If that's the case, sometimes you'll have two radicals. Step 2, you're going to raise each side of the equation to the same power. So basically, do the same thing to both sides. That's what I have written down here. Do the same thing to both sides. You guys know that, right? We've learned that in math for a long time. You got to keep that balance. So raise each side to the same power to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. The next step is to solve the polynomial equation using techniques you learned in previous chapters. So we need to solve, but we also need to check our solution because there's this thing called an extraneous solution that we can get. It's a false solution, so we have to check all of our answers. So check the solution, make sure it's not extraneous. I always look at this and I think, what's the first part of this word extraneous? Because we don't use that word very often. But what's that word right there? Yes, it is extra. So it's like an extra answer that we get that's not correct, or that does not make the equation true. Okay? And then we've got this rule down here. It's basically saying if you do the same thing to both sides, if you raise each side to the same power, they're still going to be equal. So if I take, let's do a quick example. If I take 2 times 4 is the same as 8, right? And if I raise both of those sides, if I square both of those sides, right, 8 squared is 64, and 2 squared, right? In this case, because this is a product, that power does distribute to both of these. So 2 squared is 4, and 4 squared is 16. And if I multiply 4 times 16, it does equal 64. So I can raise two equal things, two equal sides of an equation. An equation where both sides are equal. I can raise both sides to the same power, and it's still equal. Okay, so that's called Powers' property of equality. And remember, do the same thing to both sides. Okay. Now, I don't know that you should copy all of it down. I would prefer that you do it in your own words. Maybe read it, summarize it, put it in your own words. Okay. Go ahead and pause if you need more time. I'm moving on. All right, the plan for today is I am going to go through, this is going to be I do, and this is a you do. Here, let's actually spell it out. Okay, I do, you do. So that's the plan, and you guys should have this worksheet in front of you. So let's check out the first one. We've got 5 minus the fourth root of x equals 0. Now, my step said get the radical on one side, so I need to get rid of this 5, but it's a positive 5. I need to make sure I see that this is really a positive 5, so I have to subtract 5 from both sides. I'm going to draw a line right here just so I keep my my two sides straight. So these cancel, but I still have a negative fourth root here. All right. So next, I still don't have this radical all by itself. I need to get rid of that negative, so I'm going to multiply both sides by a -1. And that'll get rid of that negative. So now I'm going to have the fourth root of x equals 5. Now I am ready. So it said raise each side to the same power. Now, this is the fourth root. If I consider that as a power, it would be x to the 1/4 power. Well, to get rid of a fourth root, I'm going to raise each side to the 4th power. And the fourth root and the 4th power undo each other in a sense, and 5 to the 4th power is 625. And that's my answer, but before I'm sure that that's my answer, I need to double check. I need to plug it back in and check. So we're going to take our original equation, 5 minus the fourth root of x equals 0. And then I'm going to plug my value of x into x. So I'm going to say 5 minus the fourth root of 625 equals 0. Well, the fourth root of 625 is 5, and 5 minus 5 does equal 0. So that is true. 0 equals 0. True statement, so that is my solution. All right, I want you guys to hit pause. I want you to try this one, and then when you hit play, the answer will be there. So pause it right now. All right, so you should have gotten x equals 1. Notice I needed to, this is my work and this is my check. It's very important that we check our answers because, again, we might get an extraneous solution. All right, next problem. So solve an equation with rational exponents, basically a fraction in our exponent. So notice here, instead of radical notation, now we have an exponent with a fraction. Well, that's okay. Now, our steps said get the radical on one side. In this case, we don't have a radical, but we do want to get this all by itself. So I need to get rid of that negative. So I'm going to multiply both sides by a -1. Let's put 49. Let's get my line in there. Okay. So I multiply there and I get x to the 2/3. Right now it's positive, and this becomes negative. -49. Now in this case, I want to raise each side to the same power, and I want to get rid of 2/3. Now when we have power to a power, we're going to multiply my power and my power. So I want to raise it to the reciprocal power. If I multiply by 3/2, what's 2/3 times 3/2? 2/3 times 3/2 equals, we multiply straight across, right? 6, and that gives me 1. So that'll give me x to the 1 power, which is exactly what I want. That's why we're going to do the reciprocal. So we're raising it to the reciprocal power, same thing on both sides, right? Make sure those are the same. This, in a sense, cancels each other out. We end up with x to the 1 power. So now we have to interpret this. What does this say? This says the square root of -49 cubed. I just realized an error I made. Hopefully you've already realized it. I'm like, wait a second, if I take the square root of a negative, that's going to be imaginary. I don't remember this problem having an imaginary. Check this out. When I brought my 49 down here, I thought that was part of an equal sign, but that was a -49. Okay, so negative times negative became a +49. Oh, okay. So now I just had to go back and check. So I got my signs mixed up. That's okay. All right, so square root of 49 we know is 7, and 7 cubed is 343. All right, so I need to check my answer. So I'm going to plug this back in. The opposite of 343 to the 2/3 power equals -49. And I'll double check that in my calculator. I'm going to square it, and I'm going to cube root it, and it does end up checking out. It ends up being the opposite of 49 equals -49. All right, I want you to go ahead and pause. I want you to do this one. Remember, get your radical, but in this case, your rational exponent all by itself, and raise it to the reciprocal power. So try that. Hit pause now. All right, and that's what you should have gotten. Now, no cheating. You need to make sure you hit pause. If you didn't hit pause, rewind for a second, try it on your own, and then check your answer. All right, so we divided both sides by 3. We raise it to the reciprocal power, 3/4. We take the 4th root of 81, right, because our roots go in the ground, and our powers are up above. So then the 4th root of 81 is 3, and 3 cubed is 27. Plug it back in, just double check, and it works. Yay! All right, I think we have 2 more, maybe 3, we'll see. All right. Oh, I like these ones. These ones are fun and actually kind of easy. Oh, that's a bad word, right? It's not easy until you get it, but you're going to get it, and then you'll think it's easy too. All right, so here we go. first step, right? It said get the radical on one side. So I have this extra little piece, I need to get rid of it. I'm going to add 1 to both sides. So I have 8 over here, square root of 3x plus 4 on this side. Now it said raise it to a power to get rid of the radical. So here I have this whole thing to the 1/2 power. Now we could think, okay, 1/2, and the reciprocal of 1/2 would be 2 over 1, which is the same thing that we did on the last one. But now if it's radical notation, we can just think, okay, well, square root, we're going to square it. We need to do the same thing to both sides. So 8 squared, 64, and the square root of something squared, we just get 3x plus 4. Remember, this is, I say it's locked in a box, and you need to have this key to open this box, and once you've opened it, it drops down. All right, we just have a couple more steps. Subtract 4. Get 60 equals 3x, divide by 3, and x equals 20. Now, we're almost sure, but we have to double check, plug it back in. So 3 times 20 is 60 plus 4, square root of 64 minus 1 equals 7. Square root of 64 is 8, minus 1 equals 7. That does equal 7. All right, so go ahead. Again, I want you to hit pause. Try this one. You want to follow the steps. So hit pause now. All right, and that's what you should have gotten. X equals 94. But again, remember there are 2 parts. I need to solve it, find my solution, and then just double check, plug it back into the original equation, and make sure it works. And it does. All right. Solve an equation with 2 radicals. These are kind of fun too. All right, so I'm going to quickly walk through this, and then I think this is going to be the last one for this video. Okay, so first step. In this case, it says get the radical on one side, but we can't because there's 2 radicals. So if I tried to square both sides here, if I had to square a sum or a difference, I'd have to do first, inners, outers, last, and it would be kind of a mess. So another strategy we can use, if we have 2 radicals, we can just move one radical on one side and the other radical on the other. So notice this is a negative root x plus 3, so I'm going to add it to both sides. Right, as long as I do the same thing to both sides, we're okay. I'm going to cross this off, right? This cancels out, and on this side I have the square root of 2x minus 5 equals the square root of x plus 3. Now that I have one root on both sides, I can just square both sides. Now, as long as they're the same root, we will get rid of that radical. So we have 2x minus 5 equals x plus 3. All right, and then we just have kind of a 2-step equation from algebra 1. Sorry, we're going to add 5 to both sides. We get 8, and we're going to subtract x from both sides. And we get x equals 8. Now I want to double check, plug it back in. 2 times 8 is 16. 16 minus 5 is square root of 11. Minus 8 plus 3 is square root of 11 equals 0. Root 11 minus root 11 is 0. 0 equals 0. So we're correct. All right, go ahead and hit pause one more time. Try your own. Now, be really careful with this 3. When you square something, like if you had a 5 square root of 2x and you're squaring it, this applies to both parts because it's a product. So it would be 5 squared, and the square root and square would cancel out. You just have times 2x. But be careful, that does distribute to both parts. Okay, try it. Go ahead and pause. All right, so you should have gotten x equals 2. So you want to double check, see how here I squared 3 became 9, and I squared the square root of 2x and it became 2x. And then you're multiplying those together. All right, so you want to make sure you write down any questions you have for me, and we'll bring those into class and we can go over them in class. All right, we're going to save those last 2 examples for either in class or the next video. All right, thank you.